Hey everyone, and welcome to Astronomy Daily. I'm Avery.
And I'm Anna. We're here to bring you the most exciting space news and discoveries from around the universe.
And wow, do we have some incredible stories for you today. We're talking about surprising discoveries on Mars that could reshape our understanding of the red planet's past, dramatic developments in the new space race with Russia announcing ambitious plans to challenge SpaceX, a major exoplanet milestone that brings us closer than ever to finding Earth's twin, groundbreaking research on how ancient asteroid impacts might have actually helped life flourish on Earth, and some exciting updates on upcoming Mars missions. Plus, we'll dive into what all of this means for the future of space exploration and our search for life beyond Earth.
That's right, Avery. It's been an absolutely fascinating week in space science news. So let's dive right in with our first story, and this one's coming from Mars with a discovery that has scientists rethinking the red planet's atmospheric history.
Scientists have just discovered an unexpected ozone surge in Mars's polar vortex during winter, and this is honestly mind-blowing when you think about the implications.
It really is. So here's what's happening. During Mars's polar winter, temperatures plummet to a bone-chilling negative 148 degrees Celsius. That's colder than the surface of Titan, Saturn's moon. At these extreme temperatures, there's virtually no ultraviolet light from the sun to break down water vapor because Mars is tilted at 25 degrees, very similar to Earth's 23.5 degree tilt. This allows ozone to accumulate in ways we've never seen before. What makes this discovery even more remarkable is that researchers used data from the European Space Agency's Trace Gas Orbiter, which has been studying Mars's atmosphere since 2016. The readings showed ozone concentrations that were completely unexpected.
And the big story here is what this tells us about Mars's past. Dr. Kevin Olson from Oxford University presented this research at the Europlanet Science Congress, and he's suggesting that Mars might have once had a protective ozone layer similar to Earth's.
Exactly. And if Mars had a substantial ozone layer in its ancient past, that would have shielded the planet from harmful radiation, making it much more suitable for life as we know it. Think about this. Earth's ozone layer blocks about 97 to 99% of the sun's harmful ultraviolet radiation. Without it, life on our planet's surface would be impossible. So if ancient Mars had similar protection, we're talking about a fundamentally different world than the radiation-blasted desert we see today. It's another piece of the puzzle in understanding whether Mars could have supported life billions of years ago. And here's something fascinating. This discovery also helps explain some of the chemical signatures we've been finding in Martian rocks and soil samples.
You know, this ozone discovery becomes even more exciting when we consider what's happening with Mars exploration right now. NASA's Perseverance rover is still collecting samples in Jezero Crater, samples that could contain evidence of ancient microbial life. And with this new understanding of Mars's potential protective ozone layer, those samples become even more valuable. We might be looking at rocks that formed during a time when Mars was much more habitable than we previously thought. Speaking of space developments, our next story takes us from scientific discovery to geopolitics. Russia is making a major move to challenge SpaceX's dominance in satellite internet.
That's right. Dmitry Bakhanov from Roscosmos has confirmed that Russia is developing its own satellite internet constellation called Sphere to compete directly with Starlink. They're planning to launch the first batch of satellites later this year using their Soyuz 2 rocket. What's particularly interesting is that Russia is partnering with several countries, including Iran and North Korea, to develop this system. The project has been in development since 2018, but the Ukraine conflict has really accelerated their timeline.
The scale is ambitious. We're talking about over 900 satellites planned by 2035, with commercial services expected to begin in 2027. To put this in perspective, SpaceX currently has over 5,000 Starlink satellites in orbit and is planning for up to 42,000 eventually. But here's the thing that makes this particularly interesting. This isn't just about market competition. Russia's Sphere constellation will operate in different orbital shells, including some in higher elliptical orbits that could provide coverage to polar regions better than Starlink's current configuration. The technical approach is actually quite clever, even if the scale is smaller.
Right, there's definitely a geopolitical element here. Ukraine's successful use of Starlink during the ongoing conflict has clearly demonstrated the strategic importance of satellite internet capabilities. Russia wants its own independent system. And it's worth noting that Russia isn't the only country developing alternative satellite internet systems. China has its own ambitious plans with the Guoang constellation, potentially 13,000 satellites. The European Union is working on its IRIS-2S constellation. And even Amazon is still pushing forward with Project Cooper despite delays. We're really seeing the emergence of multiple sovereign satellite internet capabilities, which could fundamentally change how internet access works globally.
It'll be fascinating to see how this plays out in the increasingly competitive satellite internet market. But let's move on to a really exciting milestone that has me genuinely excited about the future of astronomy. NASA has officially confirmed 6,000 exoplanets. Actually, it's 6,007 as of right now, which is just incredible when you think about how far we've come.
I remember when the first exoplanet around a sun-like star, 51 Pegasi b, was discovered back in 1995 by Michel Mayor and Didier Queloz, who won the Nobel Prize for that discovery. To go from 1 to over 6,000 in less than 30 years, that's exponential progress. And the methods have evolved dramatically too. We went from radial velocity detection to transit photometry with Kepler, and now we have TESS continuing the search. There are still over 8,000 more candidates awaiting confirmation. And with the James Webb Space Telescope now operational, we're starting to actually analyze the atmospheres of these worlds.
The diversity is what really strikes me. We've got 2,035 Neptune-like worlds, 1,984 gas giants, 1,761 super-Earths, and 700 terrestrial planets. NASA's calling this the next great chapter of exploration, and I couldn't agree more. Speaking of James Webb, the telescope has already started revolutionizing our understanding of exoplanet atmospheres. Just recently, it detected water vapor, clouds, and even weather patterns on planets hundreds of light years away. We're not just finding planets anymore, we're actually studying their climates in real time. WASP-96b, for instance, shows clear signatures of sodium and water in its atmosphere, along with evidence of cloud formation. It's like having a weather report from another star system.
But here's the thing that keeps us searching. Despite all these discoveries, we still haven't found that perfect Earth twin. Every new world teaches us something different about planetary formation and the incredible variety of worlds that exist in our galaxy. And speaking of life in unexpected places, our final story today is absolutely fascinating. It involves an ancient asteroid impact in Finland and how catastrophic events might actually foster life rather than destroy it.
This story completely flips our understanding of asteroid impacts on its head. So, 78 million years ago, a 1.6-kilometer asteroid slammed into what is now Finland, creating the Lapajärvi crater.
Now, here's where it gets really interesting. New research led by scientists from the University of Helsinki shows that microbial life colonized the crater's hydrothermal system within 4.4 million years of the impact, which in geological terms is incredibly fast. They found fossilized biofilms and chemical signatures that are unmistakably biological in origin. This is the first direct evidence linking microbial activity to asteroid impacts. What's remarkable is that they used advanced microscopy and geochemical analysis to identify these ancient microbes preserved in the rock record. These organisms were likely chemosynthetic, meaning they got their energy from chemical reactions rather than sunlight.
What this tells us is profound. While asteroid impacts can certainly be destructive, we all know what happened to the dinosaurs, they can also create unique environments where life can actually thrive. The impact creates hydrothermal systems that become perfect habitats for certain microorganisms.
This has huge implications for astrobiology, especially when we think about planets like Mars or even moons like Europa and Enceladus. Impact craters aren't just scars from cosmic violence. They might be cradles for life. Before we wrap up today, I want to quickly mention that Rocket Lab is proposing something really cool. They want to build a Mars telecommunications orbiter that would provide high-speed internet between Mars and Earth. Imagine streaming data from the Red Planet. Currently, Mars missions have to rely on NASA's aging deep space network, which creates bottlenecks and delays. Rocket Lab's proposal would create dedicated high-bandwidth communication links that could handle the massive data requirements of future Mars missions, including eventual human settlements. We're talking about gigabit speeds across interplanetary distances. It's science fiction becoming reality. And SpaceX has moved their next Starship to the launch pad for Flight 11 testing. The pace of development is just breathtaking. Each test flight incorporates lessons learned from the previous ones. They've made remarkable progress with the Raptor engines, heat shield technology, and landing systems. Flight 10 successfully demonstrated controlled re-entry and landing burns, bringing us closer to fully reusable interplanetary transportation. When you consider that just a few years ago, landing a rocket was considered impossible, and now SpaceX is preparing vehicles for Mars missions, it's genuinely awe-inspiring.
What an incredible time to be alive and watching these developments unfold. From ancient ozone on Mars that suggests a more habitable past, to asteroid impacts fostering life in the most unexpected ways. From intense competition in satellite internet that will reshape global communications, to thousands of new worlds being discovered and analyzed in unprecedented detail. The universe continues to surprise and inspire us. Each discovery builds upon the others, creating a more complete picture of our cosmic neighborhood and our place within it. We're not just passive observers anymore. We're active participants in a truly interplanetary civilization that's taking its first steps.
Thanks for joining us on this cosmic journey today. Remember to visit our website at astronomydaily.io, where you'll find more space and astronomy news. And you can drop us a line too, if you wish. I'm Anna.
And I'm Avery. Keep looking up, and we'll see you tomorrow on Astronomy Daily.